seems like I'm live and my mic is working. So, oh, hello there. For those of you, of the 22 people that are subscribed to me, I'm asking you why. No, I'm joking. I mean, if you enjoy this and if you find this interesting and fun, please subscribe. So before we start, before we continue, let me just once again explain what I'm doing here. I'm having a YouTube channel. I'm usually a front-end developer. I'm actually mostly a front-end developer in the last 5 years, and I used to love low-level languages, and I used to enjoy working with C during my university times. But you know, since you start working in web, there's no more time for you to do these kinds of things. So I wanted to kind of remind myself on what the C programming language is and does. And because I'm in no way, shape, or form proficient enough to create something on my own, I'm following a book. The book's named Build Your Own Lisp by Daniel Holden. So basically, we're building our own programming language while we learn C, which is cool in my opinion. Okay, so I have no idea where I stopped last time, so let me just open my tablet as well. It's here. Yeah, it's here. Oh, let me just show you my new wallpaper. It looks nice. Okay, so let me just grab a quick look at what we did. This is the chapter. So variables is a way to name values, assign a name to a value. A way to name values. What do variables do? They assign a name to a value. They get a copy of that value. So we have an environment. Actually, what we will do here, I wrote some notes. We have an environment here that will contain a list of variables, right? Oops. I'm telling you stuff and I don't have the screen here. So these are just some things that I wrote, some bit of notes from the last chapter, from the last video regarding this chapter. So what we will have, I think we will have an environment in which we will have the list of variables, and every time we run the program, we will build a new environment. Now the command below, type def lval l built-in lnv l value will create a new type l built-in, which is a pointer to a function. So we are also learning about function pointers. Let me just get some water. My throat is dry as hell. Just a second. Oh, okay. Oops, I'm back. So, where's the pen? What we have here? We are creating a new type here. We are creating a new type here, and we encountered a cyclic type dependency in which we are actually trying to reference something before we even defined it. So we also fix this. I'm gonna remind myself on how we did this because I forgot. But what else do we have? Okay, so these are the steps what we did. We first updated the grammar, we updated the symbols. So instead of let me see, instead of having the list of symbols here, we just put a regular expression that's gonna check against some of these rules. Simple, cool, amazing. So what the hell is a function pointer? It lets you store and pass around pointers to functions. As you see, I put put a lot of question marks because I still don't know what it does, but I think I'm getting better at it. Okay. It calls a function indirectly, pass a function to another function. Okay. Here we have some methods. Okay, so let me just do this now. I'm gonna let my tablet lie on the floor. I'm gonna name this I'm gonna name this cyclic types. Cyclic types recap. Okay. So we have the new L built-in type reference. And what does it do here? Where? L, well, yeah, here. So it references the Lisp environment and the Lisp value types. So these two guys should be declared first in the source file. But as well, we want to use the L built-in in our struct Lisp value L1. Here is this guy. So we can create function values. So this declaration needs to go before this declaration. This goes before this. So, and what we encountered here is something called a cyclic type dependency, where two types depend on each other. So what we did, we created a forward declaration. It declares a function, but without body. So we do the same thing with types. What we will do here is we created two structs, types without a body. Then we type def these structs. So I think this type that. Okay. Let me see if I'm an idiot or if I understood something. No. So after we did this, we can define our built-in function pointer type, and we can define the body of our L struct. We did all of this, but let me just see. Please let me know if I understood this correctly. We declare a new struct type called L. Then we alias it the whole command to just be L, and we do the same thing to L. Is this the gist of these 4 lines of code? I'm so smart. Google, if you need engineers, please call me. Yeah, you understood it correctly. Here's the detailed breakdown to confirm your understanding. Thank you, ChatGPT. You are amazing. So this is a forward declaration of a structure called LL. It tells the compiler that LL will be a struct type, but it doesn't define content yet. So it's this guy. So both of these commands do the same thing. So what is the type they're doing? This creates an alias, so you can refer to struct LL simply as LL without any of these. It means that instead of writing struct LL everywhere in your code, you can just write LL. This improves readability and simplifies the syntax. Okay. This creates an alias we can refer. Okay. type def struct lval lval creates an alias. Creates an alias. Okay, so I'm just writing this here in my tablet, my document. You can refer to struct lval simply as lval. It means that instead of writing struct lval everywhere in your code, you can just write lval. Same thing. Summary, same thing. Okay. Now. We come to the big guy, and this is the method. So what is this one doing? I also asked ChatGPT to help me with this. It's here. So type def. We create a new alias. Okay, lval. This indicates that the function returns a pointer to a type called lval. Oh, okay. So the same thing as in TypeScript. Again, I'm being blasphemous. I'm comparing a plebeian language such as TypeScript to C, but it makes me remember stuff and connect points better. Yes, the declare cell built-in as a pointer to a function. Okay, so this is a type that can point to a function. Okay, these are just the parameters. That's it, right? That's it. Nice, easy peasy. That's it. So let's talk about function types. Let me just take a look whether I've done this. No, I don't want to exit him. Lval fun. I did this as well. So what we did, we added a new possible type, so we just created a constructor for it called lval fun. So what is being done here? We provide a function. So this is the first time here that we provide a function here, and that's it. That's it. I think the next thing to do is just take a look. Yeah, we also added new cases into our switch statements for this new specific type of Lisp value. So we have one in delete. I think we have one in printing, copying, stuff like that. Actually, the copy is a method that was added. Is the newest added method that copies an Lisp value. So I think the book said that it's gonna come. Let me check. This is gonna come in useful when we put things into and take things out of the environment. For numbers and functions, we can just copy the relevant field directly. For strings, we need to copy using malloc and string copy. Okay, that's it. That's it regarding cyclic types. Let's talk environment. I'm just gonna change colors. I like these. I don't know how are these called. These colors that lack saturation. Maybe not blue. Maybe not this because these are blue. Maybe not red here. Maybe this greenish tint. Maybe a bit stronger. Okay, I like this. So this is called environment. Okay, so what should the environment do? The environment should be a new data structure, and it says it must encode a list of relationships between names and value. Encodes a list of relations between names and values. Okay. So what should we do? Here it says we will use two lists of equal length. One is a list of levels. So two lists of equal length. So first one will be list of levels. Okay, is there maybe a better color than this one? What am I doing? Why am I going overboard with this? It's not important. Yeah, first one is the list of levels. And the other one is a list of cars. One will be cars. Okay. We already forward declared our animal struct, so we can define it as follows. Okay, so the only thing we need to do is to define it. And then we'll need to create a constructor for the L and V and a way to freeze free memory when we delete it. Okay. So let's do this. Oops. Let's define this guy. And then so define ln v and constructor and cleanup methods. Okay, let's do this right now. Okay, I need to stop repeating. Okay, we created the struct lnv. We created the alias lnv. We forward declared it, so I assume struct lnv. Only this. What should it consist of? What should it consist of? Sims files. Because this is an array. The arrays are represented like this. See, int count. That's it. Seems simple enough. Okay. Bum. Lol methods. L and V methods. So we need some function to create and delete the structure. This guy will be called, this is the return value. It will be called new void. So if anyone is interested in how I do I follow the book when I'm working on this, I try to not do. Maybe I'll take a glance and then based on this glance I create this. But basically I just read the description, which says creation initializes the struct fields, while deletion iterates over the item, both lists and deletes or frees them. Okay, so we need to create an environment, I assume, like this. And equal. Like this. We need to allocate some address space. How much? Okay, now I'm stuck. I throw a glance. So it's size of. So these are the things that I don't know by heart in C. I had a notion, I had an idea in my mind that I need to allocate a certain amount of memory to create the L and V, but I didn't know how much I need, and then ways of method. I'd say okay, so this combines with malloc and it works. So then we just need to do here count is 0. Sims is it an empty array? It's not. Empty array. It's like the TypeScript syntax. Oh god. Vals null, and then I'm just returning it, right? It's env, it's not e. Fuck it, I'm just gonna call it e. Same thing here. But wait, I'm not returning anything, I'm voiding it. Length delete. What am I providing? I'm providing the environment. I'm providing the environment. I'm providing the environment. How much am I streaming? 20 minutes already. Nice, nice. I'm hoping for an hour. It's already late. It's like 10 to 22:41 where I'm from. So I hope to finish this like quickly and then grab a good night's sleep, because tomorrow morning I'm planning to hit the gym after a long time of not doing this. Let me just do some. Actually, I won't do this right now. I'm gonna do this some other time. So, I'm deleting. What am I deleting? Wait, what am I deleting? I'm iterating through where int is 0 is less than count, right? Increase by 1. So how am I doing this? How am I doing this? I have the method free. I'm most probably freeing like this. How am I yanking? Yank is paste. Yeah, it's paste. I'm doing the same thing here. I'm freeing the well. Okay, this is the L delete. Why? No idea. Free e sims, free e vals, and then finally free this guy. Save. So what is the why am I not okay, so all of these guys have different ways of freeing memory, so that's why we didn't use just a regular old free method here. Okay. Next thing, let me just take another look at this method. It's lval, no, not lval, no, not lval. I want L and V. Okay. So, what are we doing now? Let's switch to here. It's a really pretty wallpaper. It's a really pretty wallpaper. I was hoarding them once upon a time. I had like thousands of them, and then my machine broke. I haven't done any backups. I never do them actually, and which is weird because I lost data like 5 times already. And every time it happens, I say it won't happen the next time, but it did. It always happens. Okay, so next time. Next thing. Give me the green one. What are we doing next? Next, we can create 2 functions that either get values from the environment or put values into it to get a. Okay. Get values from And so okay, the book says to get a value from the environment, we loop over all the items in the environment and check if the given symbol matches any of the stored strings. If we find a match, we can return a copy of the stored value. If no match is found, we should return an error. Okay, the second one, putting new values into and okay. So it says here, the function for putting new variables into the environment is a little bit more complex. First, we want to check if a variable with the same name already exists. If this is the case, we should replace its value with a new one. To do this, we loop over all the existing variables in the environment and check their name. If a match is found, we delete the value stored and store there a copy of the input value. If no existing value is found, we need to allocate some more space to put it in. For this, we can use reallocate and copy as okay. First things first. Let's do the get. Let's do the get. So it says here, we loop over all the items in the environment and check if the given symbol matches any of the stored strings. Hello? Get. So is this so wait, let me just think about it. We loop all the items and check if the given symbol matches any of the stored strings. If we find a match, we can return a copy of the stored value. If no match is found, we should return an error. Okay. Let's do the error immediately. It's going to be an error. Symbol not found. Okay. We handle this. Now. What should I take here? I'm taking the environment. I should also take the symbol, right? No, sorry. Here it says I'm taking this. I don't know why I thought we go. Okay. For int e is equal to 0 is less than e count abcd I int I is less than e count and d plus plus. Iterate through all of these guys. So if lval k is equal to fuck me, string compares like this. Yeah, it is. And of course the string compare needs to compare against a 0 as well. Amazing. So if the string compare compares this properly, the k symbol, right, and e symbols that I think that's it. Okay. Return lol copy was on I. And that's it. Okay, that's all. That's the whole gist of it. What's the next doing? So the other one, it says this. The function for putting new variables is a bit more complex. Okay, we want to check if a variable with the same name already exists. Logically, yeah. So if it does, we replace the value with a new one. To do this, we loop over all the existing variables in the environment and check their name. If a match is found, we delete the value stored at that location, store there a copy of the input value. how is the structure of this? So it's a void method. I'm putting something. Of course, I need to take the environment. And the new value, right? That's it. No, we did that. We did another input value. Why? Lval. Why do we need another input value? I like C because there's one way to iterate stuff through stuff, and it's this. It's a for method. You go to. I mean, you also have a while method, but you know, in TypeScript you have like a plethora of iterating methods, and all of them can be used for specific stuff, and some of them have different syntaxes and shit. But here, you know, you just write a simple for loop. That's it. Okay. So if the variable is found, delete the item at this position, replace with variable supplied by user. Okay, if string compare equal to 0, right? Yeah, it is. That's the logic. What are we comparing against? Same thing, same old. So K, the symbol at K, E, sims I. So we are comparing, we are looking for this variable inside the list of environment symbols. Okay. So if we did find it, here it says deleted. No, it's vals. But how does it know to? So most probably once we do this, the memory is still allocated, but we remove the contents of the Lisp values from this memory address. And now we're just assigning a new one. Here, copy V. Why V? What? This fucking thing. Why is V there? Why is V there? Okay, I know why. So these are broken into tokens. Tokens are, I'm calling them Lisp values because I imagine lval is a shortcut for Lisp value. But these are basically tokens, and we are comparing. Oops, we are comparing the token symbol or the variable name against the variable names, but this is a value. Okay. It's the same thing as in TypeScript, only more convoluted. Please don't kill me. I love TypeScript. So in case there's no entry, let's increase the count. So the values, what the fuck are the values? I need to reallocate memory. How? Let's ask ChatGPT. I think this is a good learning technique. So let's say I have a structure in C called sims, which is a type. And let's say I want to add a new sim in this list, but for this I need to reallocate more memory. How would I do this? Okay, you will need to allocate memory for the array to accommodate a new entry. I know this. This involves using reallocate to expand the memory space for the character array and then adding the new string at the end of the array. Here's how you do it. So you need to reallocate memory for the character array. So you need to expand the memory size to hold one more pointer in the array. Allocate memory for the new string after expanding the array. Allocate memory for the new string. Okay. So how is this doing? So sims. So assume this is the list of symbols. So I have the size. So what's reallocate doing? Okay. I'm asking it. I'm asking ChatGPT what the reallocate is doing. The allocate is used to resize the previous allocated. Oh, it can remove to a new location. Sims is equal reallocate. So what's my pointer? My pointer is sims, right? Now the size of car times e count. Ah, yeah, this makes sense. Can you please explain me why we use size of car? This purpose of this line is to resize memory block that holds an array of character pointers. So a since a pointer to an array of characters. Size of car represents the size in bytes of a single pointer to a car. This is important because okay. Same thing here. Same thing here. We increase the size. But we need to add this guy. We need to add this guy at the end. We need to add this guy at the end. Malloc string length, string str length. Okay, now I'm just copying from the book. String copy sims count -1 case. Okay. Added a new Lisp value into the vals array, added a new symbol. Here we allocated a new amount of memory. And then we copy the contents. Okay. We finish this chapter, this subchapter. Let us talk about something called variable evaluation. So this is the environment. Let us talk about variable evaluation. So we have our evaluation functions now, and they depend on some environments. We should pass this in as an argument and use it to get a value if we encounter a symbol type. So our environment returns a copy of the value. We need to remember to, okay, first things first. Evaluation function. So evaluation function. And that's it for now. So how this works? How is this working? Eval eval against the environment, looking for this value. First things first. If the type of v is a symbol, and it should be a symbol because we created a completely new list of symbols there. What should I do? I'm creating a new x length get ev. Wait. I'm not understanding this. So this is an evaluation function. So if it's a symbol, what are we doing? And we are evaluating it. So I will delete v returning x. Otherwise, if the type is an s expression, return eval s expression ev. Okay. Return v. So what I'm doing here, I'm getting a new Lisp value if this is a symbol, and I'm returning it if it's a symbol. Otherwise, if it's an s expression, we are evaluating the whole s expression. Interesting. Also, I should remove this. Oops. Can I paste it here? Yeah, I'll look at it. Okay, so function type or evaluation of test expressions also need to change. Instead of checking for a symbol, eval evil. I have okay, so I need to copy this guy completely. Where is he? Here. How many lines of code do I have? I have 110, 10 of these. 10. So it's not 10, it's 11. It's 11. It's 11, and I need to paste it. Next one, next one, next one here. I need to paste it here. Paste. This is a new line. I'm gonna remove the old eval. Okay. Let me just add this to a new line. I don't need a semicolon here. And save. So now we need to edit our evaluation of expression. So this is gonna be eval as expression. So first things first, we need to add a new environment type here. L and V environment. So because we added a function type, our evaluation of an expression also needs to change. Instead of checking for a symbol type, we want to ensure it is a function type. If this condition holds, we can call the fun field of tail. Okay, I didn't understand this. This suddenly became a bit confusing. So what's happening here? I'm iterating through this again. If it's an error, if it's 0, return V. If it's 1, return this. Pop. So if it's eval function, we are deleting it. First element is not a function. Oh, it's losing the first element is not a function. But if it is a function, f function v delete result. I don't think can I run this? There's no way. There's no way this works. There's no way this works. Variables. Yeah, there's what the fuck. Line 67. It's here. It's because it should be sims. So if I run you again, will I have any less errors? No. Implicit declaration of function will delete 68. Where is it? Here. Okay, so this all should be put. Yeah, I need to copy this and put it at the end. Okay. Mm, 53. Delete. Nice. Where can I paste it? Elbow, 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 elbow. So many buttons. I'll paste it right above here. Yeah. Okay. Oops. I paste it right about here. What happens now? Still a lot of them. 400. Where are you? What conflicting types for? Because here it should be an E. Still 400. Ah, okay. We are calling the level eval for most probably on some places, right? Yeah, we are calling it, so that's why the type can't get through. Okay, let's talk about built-ins. So what are built-ins? Let me move here. Change a different color. No. Built-ins. Okay. Okay. So we are not using symbols anymore. We have our evaluation, and instead of symbols, we are using functions. So we need to register. Register all of our built-in functions. Built-in functions. Okay. So we need to change the type signature so they take some environment. Change type signature so they get environment. Okay. Okay. Built-in add. I don't have a built-in add method. Built-in open is this. Ah, okay. So we okay. We have a completely different. Okay. Let me just read this again. So, let me just get something. Sorry. So now, actually, I just understood that we need to. Oh, we will need to update our whole code. Everything, basically. Everything. Okay, let's start and do as much as we can. So built-in list. This is the list. So instead of having only the LVL, we should also add the environment as well, right? So this should be it. There is nothing else. What else? We will have built-in add, taking an environment, taking a Lisp value. So what else? It should return built-in OP, A, and plus. Oh man, I had this everything. How? Why is this? 1, 2, 3, 2, 2, 7, 2, 3, 0. Oops. 1. Oops. Wait. 3. Yank. Paste. Another one. And I think another one. Open this guy here. This should be subtract. It should be a minus. This should be a multiplication times so we need to change all of the built-ins to the correct type, and we can create a function that registers all of our built-ins into an environment. For each built-in, we want to create a function lval and symbol lval with a given name. We then register these with the environment using lnv put. The environment always takes or returns copies of values, so we need to remember to delete these two after registration, so we need them anymore. Okay. Oh. I'm proud. My brain is fried. I need to do this better, but I have no idea anymore what am I doing. I was thinking of whether I should make it quits now or continue. I would like to continue, but I don't think as well now. I mean, let's continue. Let's try to do. No, I can't. I'm too tired. It's already late. I need to go to the gym tomorrow early. So I'm gonna stop this now, and we will continue tomorrow. We will work at the buildings, and hopefully, I think I could finish the whole chapter tomorrow. That's it. I'm sorry. For some reason it seems that I'm limiting myself at 1 hour. After that, I just stopped working, both in my real life and here. So I need like half an hour to relax, and then I can continue. I'm really sorry again for this, and I'll see you in the next episode. And